Hello everyone. I wanted to make a quick correction to the graph that I showed yesterday, the one that extends the factor field in all directions. And that is this point right here in the exact middle. Now it turns out that that should have been filled in. There's a couple of ways that we can demonstrate this, but the easiest way to show why that's the case is to actually go through another method of creating the factor field. So I've already showed the original method of going one after the other for the ones column, then every other one, then every third one, every fourth one, etc. And I've showed how you can do it with the factors of squares, like this here, and then the half squares, like this is kind of a hidden half square because it's connected there, but this is actually the half square or near square. I'm not sure exactly what you want to call it, where instead of a square multiplying itself, it's a number with the one immediately next to it, immediately one larger. So that's one method, the other method with the squares. But there's even another method to do this, which also involves loops. And that is to start here at this point, and then for the first row, we go 1 over 1 down. So that goes from here to here. 1 over 1 down, 1 over 1 down, 1 over 1 down. So that is going to build this diagonal. Then we go 1 over 2 down, 1 over 2 down, 1 over 2 down. And that's this line right here. And as you can guess, 1 over and then 3 down will get us to here. 1 over 3 down, 1 over 3 down, 1 over 3 down. And you can see that that's this diagonal row. So what I ended up doing is I'm calling this diagonal factor field, and I made some code for it. This is just one where the side is 20. And then we take the width of the graph as being the side times 2, but then we subtract 1, and that's to account for the fact that our array is indexed at 0. Then we need the side with the side minus 1. And I included this note here that we subtract the 1 to account for the 0, but side has to be decreased after width is created. And then we've got our definition of how to create the factor loop. So what this will do is we start off with a horizontal point and a second horizontal point, a vertical point and a second vertical point. And all of those are equal to this side, which is side minus 1. And then I have a variable called distance to move, and we start that off at 0, and we have the step value also at 0. Now the reason why this distance to move exists is because we're going to go through and create all the rows in the same loop. And so if we didn't have this in place, we would have to actually create separate loops for each of these with different definitions. But what we'll do here is we go through the step value. If it's less than or equal to this side value up here, then we continue to do this. And we also check for the horizontal point to be less than the width and the vertical point to be less than the width as well. So the width here, being square, is the same thing as the height in this. So the first thing we do is we take the vertical point and the horizontal point, the vertical point and the horizontal point 2, the vertical point 2 and horizontal point, and vertical point 2, horizontal point 2. This is all the stuff that when we start off with are all going to equal the side. Because the side is half of the width, this dot will, for all 4 of them, start off at the exact middle of our graph. Then we're going to move a distance of 1. And we update every single one of these. And the reason we have to use different variables is because each one has a different thing that updates it. So the first horizontal point is the side, so it's the center, plus 1, because we started with it being 0, so now it's plus 1. The second point is the same side, but it's minus 1, so it's the center minus 1. Then the vertical point is going to be the same as the vertical point before, but now the step value. And the step value starts off at 0. So the very first time, vertical point is going to stay at 0. Vertical point 2 is also going to stay at 0. It will be subtracting that. So what the first time through this loop will do is only the horizontal distances are going to be changing. So what this will do is it'll start with a dot at the center, then one to the left, one to the right. And then the next time through, this will be one more. So it'll be two to the left, two to the right. So you can see how that will build a line starting from the center going out to the edges of this graph. Then when it comes through the second time, now when we're done, everything matches up here. Then what we do is we set all of these back to the side, which again represents the center. I could have just called it center, but we're starting off by making it the width. So that's why it's called side here. And I didn't want to make more variables when they're doing the exact same thing. But again, we set this all back to the center. We change distance back to 0 because we're resetting our distance to 0. But we increase our step value to 1. So it goes from 0 to 1 here. Now it loops back again because the step value is still less than or equal to our side of 20. The second time it's going through, then it starts off with the vertical point and horizontal point, all of this stuff again, where these are all set to the center dot. So again, it just copies the same information to the center dot again. But now when the distance to move is increased by 1, and the horizontal moves 1 to the left and 1 to the right, the vertical also moves, where vertical point 1, well, I just call it vertical point, it goes up by the step value. So step value is now 1. So the vertical now increases by 1, which on the graph means that it's going down on the graph because it starts with 0, 0 at the top. So it's a little bit confusing, but this first one puts that vertical dot down by 1. The vertical point 2 goes up by 1. And so because this is going for both of the horizontal locations, because it's got horizontal point and horizontal point 2, what this does is after the first line is created horizontally, and actually let me just pull this up. So after this first horizontal line is created, the next time through, it's going to create a dot here, 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 and here. Then the step value will increase again while the horizontal step increases, and it's going to create here, 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 and here. So you can see that that's going to create this first diagonal branch off on that. Then it will do the same process again, where the distance gets set back to 0, the step value increases to 2, it repeats that whole process. So we start here and we build this horizontal line because it's not going up or down at all. Then we build the square around it and the diagonals going up. Then it's every 2 up and every 3, etc., until it's completely done. So that is the logic of how this is created. It's all done through this. We then add, of course, creating the graph code that we used before. If I wanted to create more graphs, this would be easier. I don't have to put it in a function for this one because we're only using it once, but I just kept the same function for before. And I kept the same function for updating the cell, which is called from within here. It's updated with all these values, and that just setting the value that starts off here as 1. It just sets this to become 0 at this point. So this factor loop definition basically goes through, it sets this up and it says, oh, call this. It goes through this whole process. Then when it's done, it goes create the graph. So it creates it here. And that's the whole thing. So this is what it is when we've set that to 20. So again, because it's 0 index, this is showing what 19 would be. And 19 is a prime number, which is why you get 1 here and 19 over here with no factors in between. So it is a prime number. Now, the other thing I've been thinking of when it comes to this graph in particular is how does this actually affect the way that we think of numbers? When I started the factor field, this lower right quadrant is the only part that I had originally, and it didn't have this 0. So it was just from here down to the bottom. And I was using it in Excel. So again, it was going from the smallest number up top to the greater number as you went down the list. But traditionally, we would have the origin here at 0, 0, and then positive numbers would go up and to the right. Negative numbers would go down and to the left. So with that in mind, we can use the traditional understanding of the coordinate axis here and represent 1 right here as being a factor, which is any of the horizontal dots are going to represent factors, and then the vertical will represent positive integers going up and negative integers going down. And that means that from this direction going leftwards, these would be negative factors. So the question is, if positive 1 is here, I would also be positive 1 here, but these are negative factors, which seems kind of odd, to say the least. But when we think about, say, a number like up here, this would be 6. 6 has a factor on the positive side of 1, 2, 3, and 6, right? That's just 6 there. But 6 would also be -1, -2, -3, and -6. And when you just phrase it like that, it doesn't initially make sense. But then when you remember, -1 times -6 would be +6. Then you can see how this could actually work. Now, the problem is that you could also have -1 and +6, and that would be -6. Well, we have -6 down here, so -6 this direction and this direction. So a -6 on this side would have positive integers making a negative value, or positive factors making a negative result. And that might have something to do with imaginary numbers, but I'm not convinced it is. It could just be that we have 2 negatives that cancel out again. Or when we have 1 negative, 1 positive, it's going to be on here. So I don't know if this really is replicating all of that, or if it's, again, going back to the theory of mathematical models, I don't know if this is pushing it too far. It's a good way to demonstrate the positive integers. Of that, there's no question. But once we start dealing with the negative integers, then a question can arise: is that really convenient, or is it really even useful at all to do that? So I'll leave that up to you while you're watching to give it some thought, and you can determine what you want that to be on your end. But just to show you that this code really did create this, I'll go ahead and update, and let's just make a fairly big one. So I'll just make this one to 200, save it, and then run that, and it will cause the image to refresh once it's done on here. So we hit that, and then we tell it to reopen. And now you can see that is what I'm using to make this code. So it refreshed this picture by doing that. So feel free to use this code and experiment and see what you come up with on your own. I do think, regardless of how much of this actually does represent mathematics as a whole, with the numbers like specifically, and by that I specifically mean integers, whether it only really truly captures positive integers, or if there is some logical consistency with the negative integers, whether it does or not, I do think that you can come up with some pretty impressive and amazing patterns with this. And I do think there's something fundamentally interesting, going back really quick to where this is just 20, just because when it's that big, like you just saw it, then it's pretty hard to dig into some of the details. But I do think that something that we can create, an image that we can create in 3 separate ways. The only difference between the ways is how we handle this center dot, because the way that I was looping before, going down, this would be looping with 0. And the way my loop was set up, if it's not moving to 0, it would just infinitely be stuck at this point. It would be, if you started with this. So it does work logically, but if you tried to run that on a computer, you'd have to put in a rule that for 0, it has to immediately, after it fills in that, immediately go to 1. And we get the ones column. Otherwise, you're stuck in an infinite loop and go nowhere, which is no good on a computer. But logically, it's still there in the process. It's, for 0 here, then 1 is every 1, and then every 2, every 3, every 0 has nothing. Every -1 has a complete row, every -2, -3, right? That's one way you create it. Then the diagonal, which is how this was specifically created. And then, of course, the squares, which I used to create it on this quadrant. Again, squaring a negative number, you would get a positive number out of that. And if you're trying to create this exact graph, the whole thing with squares, you do run into an issue where you might have to incorporate -1. To be completely honest with you, I hadn't actually considered any of this until I decided, without really thinking through in advance, what would this look like if I continued it on the other side. So I haven't had much time to actually think and dig into the implications of this entire graph. So there could be an easier correlation there that my brain just hasn't latched onto yet, because I've only introduced myself to this in the last about 48 hours of at the time when I'm doing this recording. So there could be more in-depth stuff that is waiting to come out, or it could just be that the factor field itself really has to be limited to just positive integers, and this whole thing is interesting but ultimately irrelevant. Who knows? But I will leave you with that thought there, and I hope you all do have a wonderful day.